Welcome to qnawire.
Okay, so this next problem is asking you to calculate certain velocities given relative motion between different objects. So again, since you're looking at a momentum chapter, you know you have a hint that you have to use momentum in some kind of way. So you have a girl, which in this case we just simplify that by an object that's sitting on top of another object that's sitting on a flat frictionless surface. Um, So if there is motion, so in this case, the velocity of the girl relative to the plank you are given as 1.5. And this question is asking you to find the velocity of the girl relative to the ice and the velocity of the plank relative to the ice. So you want to calculate these two velocities given there's just this picture. So we can essentially formulate so I'm going to draw a circle here around the system. So I'm going to call this everything inside the circle of the system. So we know that there are no external forces acting on the system, which means that the overall change in momentum in the system should be zero. So the initial momentum and the final momentum of the system needs to be zero. So the total momentum should be essentially zero for the system. So if the girl is moving this way and this plank is sitting on a flat frictionless surface, we anticipate that this plank is going to move in the opposite direction um, relative to this flat surface. So now we can just formulate equations given the information that we have. So if we want to calculate the velocity of the girl relative to the ice, we can just use the velocity of the girl relative to the plank. And then we want to now just get the velocity of the plank relative to the ice, and that will tell us exactly how fast this girl is moving relative to the frictionless ice surface here. So you've already been given this. This is the 1.5. So this equation is just 1.5 plus V P I in this case. And this will give you VGI, which is the velocity of the girl relative to the ice. So you can say that's equation one. And then, so now we want to use our momentum equations. So the final momentum of the system should be the same as the initial momentum of the system, which is zero, because again, there's no external forces acting on the system. So the momentum has to be conserved. So the final momentum when these two objects are moving is going to be just the mass of the girl times her velocity relative to the ice plus the mass of the plank times its velocity relative to the ice. All of that should give us zero. Because again, before this collision happened, everything was essentially at rest. So now we have equation 2. So now we just use these two equations to figure out VGI and VPI. So I'm going to start by getting VPI first because it's the easiest. So we know the mass of the girl, which is 45 kilograms, and we know the mass of the plank, which is 150. So if we put in 45 over here and 150 over here, and then for simplicity, we can just move these to the other side so that we can have a negative sign, what we are going to find is that VGI is actually just equal to negative 3.3 VPI. So I have an equation in terms of velocity over here and an equation in terms of velocity up here. So now I can just go ahead and substitute this expression into that equation. Hopefully I can get VPI from that. So now what I'm going to do is say, so since I know what VGI is, I can just remove that. So I know negative 3.3 VPI is now equal to 1.5 plus VPI in this case. So now notice I only have VPI in this equation, which makes it easy for me to solve it. So I can just move this over here, and then that becomes negative 4.3 VPI. And so now I can get negative 4.3 VPI is now equal to 1.5. And then I can find, once I do the division, that VPI is actually just 0.348 or something like that meters per second. So that's VPI. And notice it's going to be negative because, again, this plank is moving in the other direction of your initial motion, the girl's motion. So everything is measured relative to her motion. So you get that. So notice in this case, this is 3.3, but this is actually 3.3 with a bar because it's 3.33333 going forward. So if you do all these in your calculator, you come up with this same number here. So now once I have VPI, I know what equation I can use to, again, just get VGI. And if I use that equation here, I will find out that VGI is actually just equal to 1.15 meters per second. And that's it.